All right, this video is going to cover section 7.7 for Precalc honors. We're going to be talking about the determinant of a square matrix. And historically, determinants arose from special number patterns that occur when systems of linear equations are solved. And I'll point that out as we go. So keep that in mind as we go through this first example here. So suppose that we have a general system of linear equations and we want to solve this for x and y. So the first thing that we want to do here is we'll solve the first equation for x. So solve for x. And if we solve this for x, we're going to subtract b1y from both sides and then divide both sides by a1. So x would equal c1 minus b1y all over a sub 1. Then, once we do that, we're going to substitute x into second equation. Alright, so now we're going to have a2 times this whole thing here, c1 minus b1y over a sub 1 plus b2y, and that's going to equal c2. Alright, now we're going to solve the second equation here for y, okay, because this equation only has one variable. So let's go ahead and solve for y. Solve for y. So I'm going to distribute this a2. So I'm going to have a2c1. I'm also going to split this up into two fractions over a1 minus a2b1y over a sub 1 plus b2y equals c2. Alright, so I know this is going to be a long process here, and the point again is just to kind of eventually at the end we'll show where determinants come in when solving this linear system. Alright, so let's move everything with a y, without a y, to the other side. And I'm going to rearrange here a little bit on the left. So I've got b2y minus a2b1y over a sub 1. All I did was flip-flop these two. And then we'll move this term over to the right. So I have c2 minus a2c1 over a1. Alright, then let's factor a y out of both terms on the left. So I've got y times b2 minus a2b1 over a1. And that's going to equal c2 minus a2c1 over a1. And next I'm going to divide both sides by this whole thing, so I get y by itself. So now y is equal to, in my numerator, I've got c2 minus a2 c1 over a1 over b2 minus a2 b1 over a1. Alright, we're getting close. We're just going to simplify this a little bit. If I multiply this whole fraction by a1 over a1, then I'm going to end up with y is equal to a1 c2 minus a2 c1, and then in the denominator I'm going to have a1 b2 minus a2 b1. So here we have y, so we solve for y. Then we're going to go back and we're going to substitute this into our equation up here where we had solved for x. We're going to substitute in for y. We're almost there. So I've got x is equal to c1 minus b1 times what we found out for y. So that's a1c2 minus a2c1 all over a1 times b2 minus a2 times b1. And that's all over a sub 1. So again, all I did was I substituted in what I found for y up into this expression for x that we found in the very first step. All right, so a little bit of simplifying here. I'm going to split this up into two fractions. So I've got c1 over a1 minus b1 over a1 times a1 c2 minus a2 c1 over a1 b2 minus a2 b1. And a little bit more simplifying here. With my two fractions here, I'm just going to subtract these. So I'm going to kind of skip a step here to consolidate a little, but basically I need a common denominator here. So this fraction here, it's got the a1 piece, but we don't have the a1b2 minus a2b1. So I'm going to multiply this fraction by a1b2 minus a2b1 over a1b2 minus a2b1, and then combine it. I'm going to do all that in one step. So then I would end up with c1 times a1b2 minus a2b1 minus b1 times a1c2 minus a2c1, and then that's all going to be over my common denominator, a1 times a1b2 minus a2b1. So again, all I did was I changed this fraction so it had a common denominator by multiplying it by this piece that it was missing over that, and then did the subtraction. I kind of did that all in one step. Next, I'm going to distribute everything in the numerator here. So I've got a1, b2, c1, so I'm just multiplying this by the first term, minus a2, b1, c1, minus, now we'll work on this piece, a1, b1, c2, minus a2, b1, c1, and then that's all over my common denominator, which is a1 times a1 b2 minus a2 times b1. So let's take a look at what we've got here. I've got an a1 b2 c1 minus a1, where'd we go? All right, this should be a plus over here. So then these two terms here are going to cancel. So this term cancels with this term. And then each of the terms in the numerator has an a1, and there's an a1 in the denominator. So those are going to cancel. So that a1 and that a1 and that a1. So now, with that simplifying finished, I end up with x is equal to b2 c1 minus b1 c2 all over a1 b2 minus a2 b1. So there's my value for x. All right, so again, this was a pretty long process to get to how this is related to determinants. But if we take a look here, let's look at the denominator of both of my x and y values. So for my x, I have a1 b2 minus a2 b1. And for my y, I also have a1, b2 minus a2, b1. So as it turns out, which we're going to discuss in just a moment, this denominator the denominators of x and y is called the determinant of the coefficient matrix of the system. Okay, so I have a1, b2 minus a2, b1. So let's go back up here and take a look at what this is. So if I was going to write the coefficient matrix over here, the coefficient matrix would be a1, b1, a2, b2, and then our denominator here is a1 times b2 minus a2 times b1. So we multiply this diagonal and we multiply that diagonal and we subtract them and we get the determinant of a 2 by 2 matrix. Alright, so for a 2 by 2 it's relatively straightforward. Once we get to a 3 by 3 it'll be a little bit more complicated. I won't ask you to find the determinant by hand for anything larger than a 3 by 3. We would just use our calculator. So I'm going to end this video here. In the next video we'll look at some examples and we'll define a determinant a little bit more formally. So as always, if you have questions, make sure you get those answered, and we'll see you in the next video.